You need to hear this if you're a stargazer. What do you see when you look up at the night sky? A vast expanse of darkness, dotted with countless stars, each one a distant sun. On a clear night, you might see a faint band of light stretching across the sky. This band is not just a random collection of stars, it is something much more significant. This is the Milky Way, our galaxy, a colossal structure made up of billions of stars, planets, and other celestial objects, all bound together by gravity. It is filled with stars, planets, and vast clouds of gas and dust. These clouds are not just empty space, they are teeming with activity and potential. These clouds are called nebulae. They are some of the most fascinating and beautiful objects in the universe. The word nebula comes from the Latin word for cloud. But unlike the clouds we see in our sky, nebulae are composed of gas and dust spread across vast distances. Nebulae are more than just clouds. They are the birthplaces of stars and planets, the cradles of creation in the cosmos. They are active regions of star formation. Within these clouds, gravity pulls gas and dust together, forming new stars. They are also where stars go to die. When a star exhausts its fuel, it can explode in a supernova, sending its material back into the nebula. Understanding nebulae helps us understand the life cycle of stars. From their birth in dense clouds of gas and dust to their death in spectacular supernovae, stars are intimately connected to nebulae. It also helps us understand the evolution of the universe itself. By studying nebulae, we can learn about the processes that have shaped the cosmos over billions of years. Nebulae come in different shapes and sizes. Each one is unique, with its own structure and composition. Some are small and faint. These nebulae might be difficult to see, but they are no less important. Others are vast, stretching for hundreds of light years across space. These giant nebulae are some of the most awe-inspiring sights in the universe. They are some of the most beautiful and awe-inspiring objects in the cosmos. Their vibrant colors and intricate shapes captivate our imagination and inspire our curiosity. Did you know the Horsehead Nebula is a small dark nebula in the constellation Orion? Its shape resembles a horse's head, making it one of the most recognizable nebulae. The Pillars of Creation, located in the Eagle Nebula, are towering columns of gas and dust where new stars are born. These structures are so vast that they span several light years. The Crab Nebula is the remnant of a supernova explosion observed by Chinese astronomers in 1054 AD. It is still expanding at a rate of 1,500 kilometers per second. This material is the raw ingredient for stars and planets. Within these clouds, the building blocks of the universe come together to form new celestial bodies. Studying nebulae gives us a glimpse into the processes that created our own solar system. By understanding how stars and planets form, we can learn more about our own origins and the history of the universe. There are different types of nebulae, each playing a unique role in the cosmic life cycle. Emission nebulae glow brightly due to the ionization of their gas by nearby stars. Reflection nebulae do not emit their own light, but reflect the light of nearby stars. Dark nebulae are dense clouds of gas and dust that block the light from objects behind them. Planetary nebulae are formed when a dying star expels its outer layers, creating a shell of gas and dust. These nebulae are often spherical and can be incredibly beautiful. So next time you look up at the night sky, remember that those faint clouds of light are not just empty space. They are the nurseries of stars, the remnants of ancient supernovae, and the key to understanding the cosmos. Nebulae are a testament to the beauty and complexity of the universe, and they remind us of our place in the grand scheme of things. They are a reminder that we are all made of stardust, born from the same cosmic material that forms the stars and planets. And as we continue to explore and study these incredible objects, we uncover more about the universe and our place within it. Nebulae are not just clouds in space. They are the very fabric of the cosmos, woven together in a tapestry of light and color. They are a source of wonder and inspiration, and they will continue to captivate our imaginations for generations to come. So, keep looking up and let the nebulae guide you on a journey through the stars. The universe is vast and full of mysteries, and nebulae are one of its most beautiful and intriguing secrets. Embrace the wonder of the cosmos, and let the nebula show you the way. Thank you for joining us on this journey through the universe. Until next time, keep exploring and keep looking up. Nebulae are classified into different types based on how they interact with light. The three main types are emission nebulae, reflection nebulae, and dark nebulae. Each type tells us something different about the processes happening within them. Emission nebulae glow with their own light. They are energized by nearby stars. Reflection nebulae reflect the light of nearby stars. Dark nebulae block light from passing through them. The different colors of nebulae come from the gases they contain. Hydrogen gas glows red, while oxygen gas glows green. The presence of other elements creates a stunning array of colors. These colors provide valuable information about the chemical composition of nebulae. Emission nebulae are often called stellar nurseries. This is because they are the birthplaces of stars. These regions are teeming with the raw materials needed to create new stars, making them some of the most fascinating and dynamic areas in the universe. These nebulae are filled with clouds of hydrogen gas. Hydrogen is the most abundant element in the universe and serves as the primary building block for star formation. Gravity pulls the gas together into clumps. This process is gradual and can take millions of years, but it is the fundamental force driving the birth of stars. As the clumps grow larger, their gravity increases. This increased gravitational pull attracts even more gas and dust, causing the clumps to grow even more. This pulls in even more gas. The clumps become denser and hotter as they accumulate more material, setting the stage for the next critical phase in star formation. Eventually, the clump becomes so dense and hot that nuclear fusion begins. This is a monumental moment in the life of a star, marking its birth. This is the process where hydrogen atoms fuse together to form helium, releasing enormous amounts of energy. This energy is what powers the star and makes it shine brightly. This energy is what makes stars shine. The light and heat produced by this fusion process can be seen across vast distances in space, illuminating the nebulae where these stars are born. The Orion Nebula is one of the most famous examples of an emission nebula. It is a stellar nursery where new stars are constantly being formed. It is located in the constellation Orion. This constellation is easily recognizable in the night sky, making the Orion Nebula a popular target for both amateur and professional astronomers. The Orion Nebula is a vast cloud of gas and dust where new stars are being born. This region is a hotbed of stellar activity, with countless stars in various stages of formation. The nebula's vibrant colors and intricate structures make it a breathtaking sight, both visually and scientifically. Within the Orion Nebula, young stars emit intense light and heat, influencing their surroundings. These young stars can have a profound impact on the nebula, shaping its structure and triggering the formation of even more stars. Protostars, the early stages of star formation, can be found throughout the nebula. These are stars that are still in the process of accumulating mass and have not yet begun nuclear fusion. Some young stars emit jets of gas that interact with the surrounding nebula. These jets can create stunning visual effects and further influence the star-forming environment. Often, stars form in clusters within these nebulae. These star clusters can contain hundreds or even thousands of stars, all born from the same cloud of gas and dust. Emission nebulae, like the Orion Nebula, showcase the diversity of star-forming activities. From dense gas clumps to fully formed stars, these regions offer a glimpse into the complex and beautiful process of star birth. The Orion Nebula, with its stunning beauty and intricate structures, continues to captivate astronomers and stargazers alike. It serves as a reminder of the incredible processes that shape our universe and give birth to the stars that light up our night sky. Section 4. Echoes of Light. Reflection. Nebulae and scattered starlight. Reflection nebulae do not emit their own light. Instead, they reflect the light of nearby stars. These nebulae are made up of tiny dust particles. The dust particles scatter the starlight, creating a faint, ethereal glow. Reflection nebulae are often blue. This is because blue light is scattered more effectively than other colors. The same phenomenon makes the sky appear blue on Earth. The Pleiades star cluster is a good example of a reflection nebula. It is located in the constellation Taurus. The Pleiades is a group of young, hot stars surrounded by a blue reflection nebula. Section 5. Shadows in the Cosmos, Dark Nebulae and the Veiling of Light. In the vast expanse of the universe, there are regions where light is mysteriously veiled, creating shadows that intrigue astronomers and stargazers alike. Dark nebulae are clouds of gas and dust that block light from passing through them. These cosmic shadows are not just voids, but are filled with material that plays a crucial role in the life cycle of stars. They appear as dark patches against the brighter background of stars or other nebulae. This stark contrast makes them stand out, almost like cosmic silhouettes painted against the luminous canvas of the universe. These nebulae are very dense. The density of these clouds is so high that they can obscure the light from stars and other celestial objects behind them, creating regions of darkness in the sky. They contain high concentrations of dust grains that absorb and scatter light. This absorption and scattering of light is what gives dark nebulae their characteristic appearance, making them look like dark voids amidst the brilliance of space. Dark nebulae are important because they are often the sites of future star formation. Within these dense clouds, the conditions are just right for the birth of new stars, making them cosmic nurseries. The dense gas and dust provide the raw materials for new stars to form. Over time, gravity pulls these materials together, leading to the formation of protostars that will eventually ignite and shine brightly. The Horsehead Nebula is a famous example of a dark nebula. Its distinctive shape and the way it blocks light make it one of the most recognizable nebulae in the night sky. It is located in the constellation Orion. This region of the sky is rich with stellar activity, and the Horsehead Nebula is a prominent feature within it. The Horsehead Nebula is a dark cloud of gas and dust that resembles the head of a horse. This iconic shape has captured the imagination of astronomers and the public alike, symbolizing the mysterious and dynamic nature of our universe. Dark nebulae are scattered throughout our Milky Way galaxy, each one a potential birthplace for new stars. These regions of darkness are not just empty spaces, but are teeming with the building blocks of future stellar generations. Observing dark nebulae can be challenging due to their light-blocking nature, but with advanced telescopes and imaging techniques, astronomers can peer into these dark regions and uncover the secrets they hold. The process of star formation within dark nebulae is a slow and complex one. It begins with the gravitational collapse of dense regions within the nebula, leading to the formation of protostars. Over millions of years, these protostars gather more material and eventually ignite nuclear fusion, becoming fully fledged stars. Dark nebulae come in various shapes and sizes, each with its own unique characteristics. Some are small and isolated, while others are vast and sprawling, covering large areas of the sky. Their diversity adds to the richness of the cosmic tapestry. The dust grains within dark nebulae are tiny but numerous, and they play a crucial role in the nebula's ability to block light. These grains are made up of elements like carbon and silicon, which are essential for the formation of planets and other celestial bodies. Over time, dark nebulae evolve, with some regions collapsing to form new stars, while others disperse and fade away. This dynamic process is a testament to the ever-changing nature of the universe, where creation and destruction are in constant balance. As we continue to explore the cosmos, dark nebulae remain a subject of fascination and study. They remind us that even in the darkest corners of the universe, there is potential for new beginnings and the birth of light. This concludes our journey through the shadows of the cosmos. Thank you for joining us in exploring the enigmatic world of dark nebulae and the veiling of light. As we delve deeper into the mysteries of the universe, who knows what new wonders and revelations await us in the study of these cosmic cradles and graveyards?